A couple of days ago, I posted this video on Twitter. It's a remake of an old project I built with Houdini while trying to learn the software, only this time it was made using geometry nodes in Blender. I promised I would share a detailed video and explain my process, and here it is. We'll start with an Icosphere. It has nice and even triangle polygons. Enable the wireframe overlay in the display options. We'll instance the Icosphere onto the points of a mesh line. Make sure the offset is set to 0. The amount of the line points will determine the number of bands per polygon later on. Set this to 4 temporarily. An important thing we will definitely need to take into account throughout our setup is the index number of each instance. Let's store it using a capture attribute node. This number will be propagated down the node tree onto the polygons, edges, and points of each Icosphere instance. I'm intentionally using float as the data type for the index here. Now let's realize the instances and append a split edge node immediately after. This will generate individual polygons for each of the faces. Remember, because we instanced our sphere 4 times, we now have 4 overlapped triangles per face. Use the scale element node to scale them individually. We have the index number of the sphere each polygon belongs to. We'll need to divide it by the total number of spheres. Use the attribute statistics node to get the max index for each instance. Feed the result of the division into the scale input. Looking at the outlines gives us a feel for what is to come. The polygons are still stacked on top of each other though. We want to create non-overlapping bands out of them. Let's get rid of the faces, but keep the edges. Use a delete geometry node, switch it to faces, and choose only face mode. Append an extrude mesh node. We could extrude the edges we're left with and play with the parameters of the node to get the bands right, but instead we'll use this node just to generate the new geometry for the bands. Set the offset scale to 0 and add yet another scale element node. We will scale edges this time, and only those that are part of the top selection from the extruded geometry. Sliding the scale value, we can try to close the gaps between the edges, but because the triangles have different dimensions, a single value won't do. We need to calculate a different value for each edge to cover the same gap distance. Again, the indices of the edges correspond to those of the sphere instances. Let's map the indices into a range from 0 to 1. Add a math node and divide 1 by the index number. Do not connect the result to the scale input yet, but subtract it from 1 and feed this new result instead. You might think that this new geometry looks exactly like the one before we deleted the faces, but to prove you wrong, let's do a test. I'll remove the bands one by one so you can see the result. Add a new delete geometry node and switch the mode to faces. Use the index information again and compare the indices against the chosen number. Connect the result to the selection input of the delete node. Now slowly increase the index value and see the bands getting deleted one by one. Curiously, when the index is equal to 0, no band looks like being deleted. Thinking about it, the band with the index of 0 is scaled down completely in the middle of the polygon, so deleting it for good doesn't affect the look of our geometry. Instead, it helps optimize it. The example video showed a spherized body, So the next step will be to create a spherized deformer. We might have used the classic cast modifier, but we'll build our own deformer using nodes. Besides, it's surprisingly easier than you might expect. Add a set position node. To project our mesh onto a surrounding sphere, we will use the position vector of the points as the direction. First, we normalize the position vector using a vector math node. Then we set the radius of our sphere with another vector math node by scaling this direction vector. Mix both position and the spherized position vectors with a mix RGB node. Connect the result to the position input of the set position node. Play with the mixing factor to interactively turn the spherized effect on and off. For a smoother result, remember to increase the subdivision level for the edges that make up the bands. Also, you can create more bands by increasing the number of points of the mesh line. All that remains now is to animate the bands in a wavy motion. We'll make use of yet another extrude mesh node. This time we will extrude faces. Leave the offset scale to 1. We will work on the offset vector value. Again, get a position node and connect it to a vector math node with the operation set to scale. The wavy motion needs a sine function. We'll map the -1 to 1 range of the sine wave into a new range from 0 to 1. The wave frequency will be based on the band's index number. The index is inherited from the instance index. We will add time to the index to animate the value constantly, but before that, let's make sure that this animation is loopable. Add a map range node, go to the Frame Range tab in the Properties window, right-click on the Frame Start field and choose Copy as a new driver. Then paste the driver on the minimum input. Do the same for the frame end, copy it as a new driver and paste it on the maximum input. Now click on the maximum output field and type hashtag 2 times 2 times pi. This will make sure that the wave is repeated twice during the length of the timeline. Someone on YouTube mentioned this in the comment section of my previous tutorial. To make the loop precise, we need to subtract 1 frame from the start of the timeline range. Let's do this. Right-click on the minimum field and choose Edit Driver. In the window that pops up, choose Scripted Expression from the Types drop-down, then type -1 after the variable name in the expression field. Add the result to the index number, hit play, and there you have it. To speed up the animation, add the driver of the maximum output and increase the looping times number. To manually set the offset between the bands, multiply the index by some custom number. Also, change the radius by tweaking the offset scale value in the extrude mesh node. Now you can freely change the initial mesh type with any type of solid object. If you want pentagon bands, add a dual mesh node after the icosphere. You can use a cube also, or a cylinder. You can also disable the spherize effect for a sharper look. Experiment at your own will. If you come up with something interesting, I'd love to see it. And if you like the video, please share the knowledge.